Hi, Andrew here from the Glaser Tutoring Company, and today I would like to teach you how to use the Rational Zero Theorem to find the real rational zeros of this nutball function. So, how do we do this? Well, first thing is you got to know what the Rational Zero Theorem is. So, what it says is that if you find the factors of your constant term, remember the constant term of your polynomial does not have a variable attached to it, and you call those factors p. And you find the factors of the leading coefficient, which remember the leading coefficient is found next to the highest power of x in your polynomial, and you call those factors q. Then if you take the p factors and divide it by the q factors, you're going to get a list of possible rational real zeros. Some of them might be zeros. None of them might be. It all depends on the problem. But it's going to give you a list of possibilities. So now what we'll do is let's list out the factors of 6. Right? So two whole numbers that multiply to 6 is 1 and 6, or 2 and 3. And every time you write out your factors, always write plus minus, okay? Because technically either one will work. And then you got to list out the factors of your leading coefficient. So it's 8. So that's going to be a 1 and an 8, or a 2 and a 4, right? 2 and a 4. Okay, and again, plus minus for every one of those. Now what you have to do is you have to now create your list. Basically, you're going to take each individual denominator divided by each individual... That's the numerator. Each individual numerator, each individual numerator and divide it by each individual denominator. So plus minus 1 divided by plus minus 1 is going to give you a plus minus 1. A plus minus 2 divided by a plus minus 1 is going to give you a plus minus 2. All right, plus minus 3 divided by plus minus 1 again is going to give you plus minus 3. Then you're going to get a plus minus 6. Then you got to repeat the process. You got to do plus minus 1 divided by plus minus 2. Yay! That's going to give you plus minus 1/2. Then you got to do 2 over 2, which is a positive plus minus 1. You already have that, so don't list it. Then it's 3 over 2, right? So that's going to be plus minus 3 over 2. Great. Then it's going to be 6 over 2, which is a 3, which thank goodness we already have, so you can skip that. Okay, then you got to go to the fourth. You got a 1 over 4. Okay, great. 1 over 4, this is fun. That's one of them. Then you got 2 over 4, that's 1/2, but you already have that, so skip it. Then you got 3 over 4. Oh, that's joyful. Great. And then you got 6 over 4, right, which is really equal to 3 over 2, which we already have, thankfully. And then, you got to do it again. 1 and 8. Great, that's new. 1/8. 1 over 8. Then it's 2 over 8, which is a quarter, which you already have, thank goodness. Then it's 3 over 8. You don't have that one, so that's going to be plus minus 3 over 8. This is fun. And then last but not least, you're going to have 6 over 8, right, which that would reduce down to 2. Oh my God, my brain can't work. 3 over 4. 3 over 4. And we already have that. Okay, thank goodness. So this is the list. Now, how many things do you have on this list? Well, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But they're all plus minus. So you have 20. So to use this theorem without a calculator now, you'd have to test all 20 values. And hopefully you're going to get 4 of them. Hopefully. You might not. You might get none of them. Okay? The idea here, though, is that this provides a list of possibilities. All right? Maybe your zeros are in there, maybe not. But the way that you're going to test it now is you're going to take one of the values. Let's do 1 because that's nice and easy. And you're going to plug it in everywhere you see your x. Okay? Everywhere you see your x. So plus 39 times an x squared plus 26 times that x plus 6 equals 0. So the question is, does this thing equal 0? If it does, then the value you plugged in here is going to be a 0 of the function, meaning it's an x value that gave an overall result of 0. Is this going to give 0? No. No. So what that means is that positive 1 is not a 0. Well, great. There's 19 left. This is very inefficient. Okay? So how we're going to cut down on this, otherwise the video is going to be 17 hours long. What we're going to do is we're actually going to gain a little bit of insight from graphing it. All right? Let's see what the thing looks like. So do 8 x raised to the 4th, then do plus 26 x cubed. All right, then do plus 39 x squared. Okay, then do plus 26x, and then do plus x. And almost made. Oh, that would have really sucked. Plus 6. Enter. No, not enter. Graph. Let me zoom out a little bit, okay? Let's zoom because it might be doing something funky. Let's zoom. Let's go zoom standard 6. All right. So I'm pretty certain. So I'm going to zoom back in. So this thing is not going to come back down at all. So this thing is not coming back down. So let's zoom in. Let's go to 2. All right. And hit enter. Okay. So basically now I notice that I have some zeros. All right. And I notice that I have 2 real zeros. Okay. Real zeros are always found at the locations where the function crosses that x-axis. All right, so these are going to be real. I don't know if they're rational, but they're definitely real. They're definitely real. So if I had to think about my list over here, you know, this looks pretty much halfway in between, right? So maybe this is a negative, and each one of these tick marks represents, by the way, 1. So maybe this is a negative 1/2. So x is equal to negative 1/2. And then the x over here, it looks like that's maybe equal to 3/4, 3/4, you would say, right? Maybe negative. So x is maybe equal to negative 3/4. And are these values on our list up here? Well, yeah, right. Negative 1/2 is found right here, and negative 3/4 is found over here. So these are possible. Now, from looking at the graph, you don't really know if those are exactly the right values. So what you will do now, what you can do, is you can plug these values on into your function, all right, and evaluate it. So watch. So let's clear this out. All right, let's go to now 8 parenthesis now. Let's do negative 1/2. Okay, so negative 1/2. Close the parenthesis then and raise it to the 4th. Whenever you plug in x values, please plug them in parentheses. So, and don't, sometimes when I speak, I forget to do things. So plus 26, then it's x, so it's negative 1/2, right? Raised to the 3rd. Okay, so that looks good. Then it's going to be plus 39. Why 36? What's going on? 39. All right. Then that's going to be parenthesis, then negative 1/2 squared. All right. Then it's going to be plus 26 now times your x, which is negative 1/2, plus 6. Hit enter. Oh, thank goodness. It worked out to be 0. And that's the idea. Okay. That's the idea. It's going to work out to be negative 1/2. The 0 value is negative 1/2. It worked out. It produced, when we plugged it into this function, it produced a value of 0. That's what it means. And we could do the same thing then for the negative 3/4, but I think I'll skip that for now. All right. It should work out. So these are the only real zeros because when we saw it from a graphical perspective, it only crossed the x-axis 2 times. So whenever it crosses or touches that x-axis, those are the real zeros. Now the thing is, if I know I have two real, what kind of word is that? It's supposed to be real. Real. If I have 2 real zeros, and I know I'm dealing with a quartic, remember the number up here tells me the maximum number of zeros I should have. So if I have a maximum of 4, but I only have 2 real, where's the other 2? Well, they're out in imaginary land. That's where they're going to be. Okay? There's 2 real, and then there's going to be 2 imaginary. 2 imaginary zeros. Now, for this problem, we just had to find the real zeros, so we're done. All right, we're done. If, though, you had to find the imaginary zeros from here, what you would do is you would basically do this process. I'll outline it for you very quickly. What you would do is you would divide now this function by the factors of these zeros. In other words, by x plus 1/2 and x plus 3/4. Okay, you would multiply this on out. You'd FOIL it, x times x, then x times the 3/4, etc. Blah 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 blah. You get some quadratic function down here, x, plus something, blah 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 blah. Then what you do is you do a long division. You're going to take this polynomial and divide it then by this polynomial. And what happens is when you take a quartic and divide it by a quadratic, you get a quadratic as your quotient. So the outcome of this is going to be, so when you do this division, you're going to get something in the form of ax squared plus bx plus c. All right, where after you do the long division. And then what you're going to do is you're going to use your, if you can't use the calculator, you're going to use your quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you identify your a, your b, and your c, and you plug it on into this formula, and voila. You're going to realize that the value under the radical here is going to be a negative value. All right, it's going to be a negative value. And that means that they're going to be imaginary. All right, there's going to be some imaginary zeros in this problem. So hopefully that kind of outlines it for you. It's not really the point of this problem, but just to give you a little bit more information, that's how I would approach it then from there. All right. And if you like what you see, check out some more of the videos here. I think I have, I don't even know, 15 problems dedicated to just this one type of question. So if there's something you feel like, that maybe I didn't explain fully or something like that, generally speaking, what I try to do in many videos is I explain it differently or slightly differently. I try to approach it in a slightly different way. And in that way, I don't know what might work for one, might not work for another. So I try to be as generous in that fashion as possible. So check out some more of the videos, all right? And keep doing practice. And we have thousands of videos out there, not only in math, but chemistry and physics as well. We want to help you through your class. The best way to do well on your tests is to practice, do problems. That's what we specialize in. All right, we specialize in providing support and help for you through your practice. And we also provide one-on-one tutoring. So if you want to continue lessons with us privately, send us an email. We'll talk to you soon. Take care.